Hello, my name is Aaron with iBoard Repair and iPhone Data Recovery, and today I'm going to be working on an iPhone 11 Pro. So I have it here in front of me already. This one is a severely cracked one. So I have a cracked screen over here, cracked back over here. I think they actually said this one was even ran over. The inside looks okay. It doesn't look too bent, so that's nice to see. I haven't done too much yet, but I've removed the screen and I've unplugged some cables. And all I did was test to see what it's doing on my DC power supply up here when I prompt it to boot. See if you can get that in frame. Yeah, it looks barely in frame for you. So if I take my DC power and I touch it to the battery connector here, you can see right off the bat that I'm getting an amp draw. So that means that amp draw before prompt to boot means that I have either a VDD main short, a VCC bat or bat VCC short, a boost short, or a few other lines. But most likely it's going to be VDD main. And I'm curious to see if I'm going to see like a smashed chip on this or what. But yeah, I'll take this motherboard out and we can get started on it right away. I always check with my DC power supply first, whatever I think the problem's going to be. I check to see what that does when I connect the probes to the battery connector, because that's always going to give you a lot of good information. And this one is telling me right off the bat that there's a mainline short on here. So one moment, I'm going to remove this board out of the housing and we'll go from there. All right, I have the board out. So I'm going to go straight to splitting this board. Honestly, it doesn't look too bent or anything, but something's wrong, obviously. So I guess I can see if I have any main on the top of the board here, and then I can just like see if the problem might possibly be on the top board on the top, and I won't have to split this. I don't know if that will be the case, but we can see right now. See if I can find main somewhere. There's main. Okay, so I have main right at my LCD image FPC here. So right here. Yep, so I have a main short, because that should not be ground. And there's not very much main on the top board after all, so I'm just going to go ahead and split this because I'm pretty confident I'm going to have a problem in between. So I have my preheater here. I preheat this, or I heat this at about 190 degrees for about 3 minutes, and then I pull the board apart. So I'm going to set my timer on my phone for 3 minutes here. And then I'm going to pause the video and come back once that's ready to pull. So it's been about 2 minutes and 50 seconds. So this should be ready to pull pretty soon. Let's see if it wants to release. Yep, it's coming off. Okay, so I do have some broken pads. Let me turn this heat off real quick. Let's take a look at the board that actually matters. The top board. So I don't see anything cracked, which is nice to see. So let's see if if VCC main is still short, or VDD main I should say. And it is still short. So the short is going to be on this side of the board. So we must find it then and clear it. So the way I find VCC main shorts, I think is the simplest way. A lot of people have a lot of tools that they use in order to do this. A lot of people will power these boards through the battery connector to find the short. I really don't like using that method because you're starting on a line that's not short and you have to connect it to the line that is short, or you have to allow it to go through a chip that's connecting the line, and it's just like an extra step that doesn't need to be there. So I just use my DC power with probes and I touch voltage directly to the line, and that way I know I'm working on the line that's actually short, and I'm not having to be worried about the line going through like some other coils or something else into a different line. I just use freeze spray and DC power. So let's see if I can find where the VCC main caps are. Alright, I'll inject into this one right here. And we'll see what heats up. So it looks like the right side of that cap is the line, so I'll go ahead and do some freeze spray. Oops. Zoom out a little so we can see better. And the right side of that line. So we should see the cap heating up, or whatever it's going to be, in just a few seconds. So maybe I was wrong, it is actually on the front side, and that's going to be annoying that I split this if that's the case. There's something over here was heating up. I wonder if there's main underneath here. Let me see. No, I'm not seeing any main there. Oh, how odd. Main actually is the battery connector in on this board. I didn't actually ever realize that until now. Interesting. So I didn't see anything heat up. I'm going to heat up this side just to make sure that's not something on this side. But there's not very many spots it could be on this side. And I guess I was just saying I don't like to go in through the battery connector, and that's because typically the battery connector is not main, but now it is on this board. I gotta make sure this is all dry first. To me, that was very, very unclear again. Let's try this side again. Alright, I'm going to focus on specific locations on this board so nothing gets by. The first thing I'm going to look at is this section zoomed in. So there's a lot in this area that it can actually be. It can be any of these little caps that are up against the CPU. It could be this cap. It could be this cap. This cap. A bunch of little ones through here. And more over there, but I want to look at this area first. Not usually so hard to find, because I'm not seeing it anywhere yet. It could actually be underneath that shield, which would be hard to locate. It could be any of these caps around the PMIC. So this time I'll look at the PMIC area. And I'll inject into this little cap here. Oh, there it is. So this one right here is what showed up. Okay, so that's fine. It's going to be the very first one right there by the PMIC. This is the problem. And if we zoom into that thing, you know, it looks perfectly fine. I don't see anything wrong with that one. And that's why I always like to go, when I'm having trouble finding it, it's usually a small one, and it's usually necessary to go like section by section like that, where you stare intently at one section, move to the next one, stare intently at that. Then you can usually find it. So I think I'll put this in a board holder to help. See if I can just pop it out already. I don't want to get too close to that PMIC. Ow. That's still hot. I touched that metal part, but it came out, so that's good. So now the line should no longer be short. And just for like the sake of keeping everything the same, I'll measure this at the LCD FPC and also the battery FPC. So I had been measuring from here, so let's see if it's going to show me short still. It's probably the only one, but I guess there could be another. So it's just showing a partial short, and that's only showing that because it's still kind of hot. So if I just cool it down, that should go away. There we go. It's still a little lower than what I would expect. I haven't taken very many diode motor readings on the 11, so I guess I'm not 100% sure what a normal reading is. Easiest way to tell, let's just see if it's still taking amperage. And no, there's no amp draw through the battery connector anymore. So now if I prompt this to boot, I should see the beginning of a normal boot sequence. And I can put this, I guess I'll go ahead and put this in the jig. That bottom board is missing some pads, but I think it will be good enough to not have to update it, hopefully. I forgot which button prompts that to boot. Let me double check. There we go. Okay. So yeah, that looks like the beginning of a normal boot sequence so far. That will continually raise into the 20s and then up higher, but that looked good enough to me for now. So what I'll go ahead and do now is I will clean up this bottom board a bit, and I'll put this in the jig. And as long as none of the lines that are missing are too important, then I shouldn't need to do an update or a swipe to recover screen. I like to avoid those screens if I possibly can. I only removed this solder, what is this called? Solder paste or thermal paste, because I'm about to clean this outside with alcohol and it's just going to make this a mess. Good enough. So it should be good enough, so I'm going to go ahead and grab my jig and connect it. And I expect to see a full boot at this point. So one moment while I grab that. Okay, so I have my battery, my charge port, my power button flex, and my jig. And let's see if this wants to boot how it is. So bottom board, my my interposer thing, top board, top of jig. My charge port. My power button. Power button's required on the iPhone 11 because it has a sensor, a thermal sensor that it checks in on, and if it can't read it, it'll reboot the phone every 3 minutes, and that will prevent me from pulling data. That's why you need the power button. Here's my charge port. Oh, I didn't need to plug that in yet because I need to put the screen on still. That's the one thing I forgot. Let me grab a screen. I actually have a screen right here in front of me. So let's try this screen. Plug the battery back in. And let's see if it's going to boot and if it's going to be available to pull data. Okay, so I am getting an Apple logo. I'm realizing you can't really see that, but that's fine. I can just go to my screen capture and you can see it on 3U. And there we go. It's recognizing it already. I'll have to put in the passcode to see what that is. 4218. Still on the Apple logo. It might take a minute or two. Yep, we're in. There's actually no passcode on this phone, so that's odd. Doesn't matter. It's going to want trust still, but it's not prompting me for trust yet. There it goes. Device timed out. Let me plug it back in. Alright, and I'm in. I have access to the data, and I'll start to pull this. I mean, I guess I can show you the next step of my process, which isn't too complicated. I just go to my PC, I go to my external hard drive. I save all my data, all my iTunes backup on an external hard drive, otherwise my computer hard drive would be completely full. So I create a folder in there, I go to 3U, I go to backup and restore. I always take note of like all this additional other space. Usually that's like unallocated and it doesn't actually even do anything. It's weird because so many of these phones are just completely out of storage space, but there's 100 gigs of unallocated space. So it's weird. So backup, I'll go over to my backup path, which is inside my Seagate here. This is Troy H. And I'll back up now. So it's a 213 gig backup, so it's going to take quite a while. After I do the backup, I get the backup secured on my hard drive, and then I transfer it to a flash drive, and while that's transferring to a flash drive, I also run alt data, and that parses the data for me, and that's kind of my whole technique that I use. Obviously, I transfer the alt data to a flash drive as well. But that's the video. This one was very simple. It was just a VDD main short, and it was just the tiniest little cap that went wrong. There was no water damage or anything. It was just an impact. The impact must have sent some sort of voltage spike on the board, and that capacitor seemed to take the brunt of the voltage or something like that, and that caused that cap to go short. Once it's removed, that's all that needed to be done. Since the board's in the jig, it's very easy to pull the data from it, and customers can be real happy with this one. Thanks for watching. Hope you watch again. I kind of want to change the format of my videos. I'd like to kind of get to up the production value of them, make them a little bit better. But for now, I'm still kind of just doing these live recordings that I'm just uploading without doing any type of editing to. If you are interested in seeing some other format, let me know in the comments, like kind of what you would like to see. If you do like to see this kind of open format where I just open up a device that I've never diagnosed yet and kind of just work through the process with you, let me know if you enjoy that process as well. I'm just not quite sure which way I should take the channel. But anyway, thanks again for watching. See you later. Bye.